All right, guys, so the next part of this unit is the area of regular polygons. So before we can really get into the area of regular polygons, we have to do a little bit of review and a little bit of new definitions. So today's lesson is actually going to be split up over 2 days so that you guys don't have to watch all of the video, which is, I'm going to try to keep it as short as possible. But it's going to be a little bit longer, so you don't have to watch all of it on one day. You can watch the definition parts one day and the actual area part another day. So let's go ahead and jump into kind of some of this review and definition piece. So the first part of the review is going to be, what is a regular polygon? So hopefully you guys remember that a regular polygon is a polygon that is equiangular and equilateral. So these two words here are a little bit, different, maybe a little funky, but remember, equiangular just means that all of my angles are congruent. Equilateral just means all of my sides are congruent. So if I were to mark that in this image, I would just mark all of my angles congruent and all of my sides congruent. Hopefully remember the sum of the measures of the interior angles of a regular polygon. So what would all of these angles add up to be? That's when we used our 180 times n minus 2, where n was the number of sides. Now, if I wanted to find just the measure of one of those interior angles, rather than the sum of the interior angles, I would just take that equation from above and divide by the number of angles that I have. So to find the measure of one interior angle of a regular polygon, I just do the sum of the interior angles divided by the number of angles. So let's just put that to the test really quick and do 2 quick examples of the interior angle measure of each angle of these 2 regular polygons. So since I'm looking for the measure of each angle, hold on, let me switch colors really quick. Since I'm looking at the measure of each angle, I want to use this second equation here. So if I'm doing the one on the left here, let's count the number of sides that I have. So 1, 2, 3, 4, 5, 6. So my number of sides equals 6. So I could just plug in 180 times 6 minus 2 divided by 6. So I would have 720 divided by 6. So each angle is 120 degrees. So that just means each angle inside of here I would label as 120 degrees. All right, for the second one, again, I'm going to start by just counting my number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if I have that 180 times my number of sides is 10 minus 2 divided by my number of sides. So 180 times 8 is going to be 1,440, and then I'm dividing by 10, so I get that each angle is 144 degrees. So we want to keep this in mind kind of as we're going through this unit, because we are going to want to be able to find the measure of each angle of a regular polygon as we're solving for the area. All right, the next thing, this is going to be kind of the new ideas and definitions. So for some reason, the image actually popped up to the top of the screen. So if you guys want to either use the image up here by our old definitions, or if you want to draw something new by our new definitions, feel free to go ahead and do that. So new ideas and definitions. The first thing is any regular polygon can be inscribed in a circle. So inscribed just means that we could put it inside of the circle, and every vertex, every corner of my polygon is going to be touching the outside of my circle. So if you guys look here, my polygon at each one of these vertices is touching, just touching that circle. So this polygon is inscribed in my circle. So whenever I talk about the center of my regular polygon, I'm talking about, and we can think of this one in two ways, the center of the circle that I'm inscribed in, or you can also think about it as the point that is equidistant from each vertex. So as you're thinking about this, if I had a point, outside of my circle way over here, it's not going to be an equal distance from all of my vertices. So the only point that does have that equal distance is that center point. All right, the next thing that I want to talk about is this, is the radius of a regular polygon. So radius, hopefully you guys have seen this word before when talking about circles. So a radius of a circle goes from the center of the circle to that outside point. Well, the same thing is going to be true for a regular polygon. It's going to be that distance from the center of the polygon to any one of its vertices. So if I'm looking at this image here, my radius is going to be this distance here that's going from the center out to the vertex. I'll just make that point a little bit bigger so that we can see it. All right, the last thing that we're going to talk about here, kind of that last new definition that we're going to need, is this word apothem. So an apothem is going to be a line segment from the center perpendicular to any one of the sides. I'm going to kind of block these off a little bit so you can see them a little bit better. But so an apothem, it's going to be that line segment from the center to any one of those sides, and it's perpendicular. So this blue line that we have on this polygon here. So those are going to be our new definitions. So let's just practice those really quick. And that will be all for this video. So you guys have this image. And so what I'm going to do is I'm just going to draw in a couple different lengths. And I want you guys to determine and think about what is the radius, what is the apothem, what would my perimeter be, and then what is the central angle measure. So that last one is going to be kind of a new idea. We haven't talked about it yet. So start with the radius, apothem, and perimeter. Take a couple seconds, pause the video, and try to fill those three out. All right, so first one is going to be the radius of my pentagon. So the radius is that length from the center to one of my vertices. So that is going to be my 4 centimeters. The next one is the apothem. So the apothem goes from the center and is perpendicular to one of my sides. So that will be my 3 centimeters. And the perimeter is going to be going all the way around my shape. And remember, since this is a regular polygon, I know that all of my sides are congruent. So I can do 5, which is my 5 centimeters, and then multiply it by the number of sides that I have, which is also 5. So that means my perimeter is going to be 25 centimeters. All right, and the last thing that we're looking at is the central angle measure. So the central angle measure is and I want to look at, I'm going to go ahead and draw in this little angle right here. I'm looking for this central angle measure. I'm just looking for this angle that is around the center of my circle, or of my pentagon, sorry. So if I'm wanting to find this central angle measure, I want to think about, okay, if I have this angle that opens up to be one of the side lengths, I know that I can create 5 triangles that all have that same angle there in the middle. So 1, 2, 3, 4, and 5. So if I look at this, if I go all the way around this center, I've gone 360 degrees. So if I just want one of those angles, I've only gone 1/5 of the way around that center. So to find the central angle measure, I can do 360 degrees divided by this 5 here, which is the number of sides. So I would find that this is 72 degrees. So I can put that in here, that I have a central angle measure of 72 degrees. All right, so that is what we're going to do in this video. So today and tomorrow, you're going to do this video, you're going to watch the next video, and you guys have some homework to look at. So go ahead and keep going.